You may begin.
Alright, so hi class. It's a beautiful day outside, and I come here to talk to you about something special. Imagine if you could just print out a house, or print out a car, or if you could print out a cake. Technology has advanced to such a point that this can happen. So, as a mechanical engineer, this field is a very high interest of me, and we worked with it since the start. And according to my survey, most of you know what this is about, know what can it be used for. I'm here to talk about the history of 3D printing, its different methods, and what it can be used for. So to begin, 3D printing is a name for a process that, according to an issue of the journal Technology and Engineering Teacher, spring of 2015, called Rapid Prototyping, which refers to a relatively quick process that produces unique objects according to custom specifications. Also, according to one of my engineering class textbooks, SolidWorks 2021 and Engineering Graphics, an integrated approach by author Randy S. says that 3D printing started after computer-aided design, or also known as CAD, became one of the most important requirements for engineers and designers. These were the beginning steps for the process that we know as 3D printing. It didn't really take off before the arrival of computers to the industries, because it was rather difficult for a single person to design these things. They had to use different tools, and it was just overly complicated for a single person. And at the same time, the 3D printing became a feasible subject. Different methods arose by different people. To quote the textbook again, SolidWorks 2021 and Engineering Graphics, the integrated approach by Randy S., there are multiple methods for 3D printing objects. For example, there is this method called stereolithography, or SL or SLA for short. Also, there is the method called fused deposition modeling, which is FMU and FFF, and laser sintering, LS or SLS. These are the primary methods that one would consider that are the standard for 3D printing. And all these methods have this single similarity, that according to a book called Mastering 3D Printing by author John Horvath, said that these 3D printing methods are constructive manufacturing, which differs from all standard methods, as instead of taking pieces away from a single object, you add layers on top of each other. You're adding to construct a thing. And these methods differ a lot. For example, SL, or stereolithography, consists of a laser and a container filled with resin. And this laser works to create a shape by scanning layer by layer and curing the resin into a solid. And so this method, at the end of the process, requires further refining. It might be needed to be cured, sanded to meet the specifications, and most 3D processes also share the fact that sometimes you need support for more complicated or complex characteristics of the design. Like if you're trying to create, let's say a robot, and you want to create the arms, you're going to have to put in supports for the arms if you want to create the whole thing, or you can create it by pieces. Overall, mostly hanging objects need supports, and this can also be done by using materials that can be diluted by a solution, or that are way less stronger than the main material, so they can be broken off easily. Alright. There's this other method that I talked about, FFF, which is the most common one that I very sure think anyone here has seen, where they use molten plastic to create the shape layer by layer. This basically gets rid of the liquid resin that the SL use and is overall more simpler. With all those different processes that one can use to print things that are tangible, there has to be some way that different industries can integrate this into their methodologies and specialize. So, according to my survey, most of you know what 3D printing can be used for, and that's a great thing, honestly, because then I don't have to go into that much of a detail. But according to a publication in the International Journal of Advanced Manufacturing Technology, spring of 2016, explains that tissue engineering aims to develop biological substitutes to restore, maintain, or improve the function of novel, damaged, or degenerated tissue and organs. So basically what this article says that the medical field can use 3D printing to create things such as replacement tissues, skin grafts, so we no longer relying on a donor. We no longer have to take the skin from one side of the body. We can just print it out. And also another journal talks about another application for a different industry. So this industry is the furniture industry. So according to the journal Scientific Programming, summer 2022, it claims that the manufacturing of 3D, the integration of 3D printing technology is crucial to reducing the repeatability in the product development process. So 3D printing has allowed to shorten the amount of work it's needed to create furniture. The design process, less people, more automated. Overall, a benefit to the industry. And now since we talked about the history, its methods, and its uses for different industries, I'd like you all to think about which places can 3D printing be useful for? Think about what can you do with it? Is there any other field that could benefit from it? Thank you.